Hi everyone. So the next section we are looking at in our trig chapter is basic identities. This is section 4.4 in Algebra 2a. And so I'm going to pause for a second and let you get down the definition of identity, and then we're going to kind of talk through this first identity. And then I will tell you I'm going to go off script just a little bit because I think I can explain the rest of this lesson in a much easier way than what you see on the next page of your notes, and I'll kind of talk more about that when we get there. But an identity, and if you need to pause the video to get the definition written down, that's fine. But it's basically an equation that represents a relationship between different variables that's always true. Essentially, it's a formula, okay? But we tend to only use this phrase identity when we're talking about trig, because there's all these relationships between like sine, cosine, and tangent that we're going to be exploring. Okay. Our next step, just so you know, is moving into not only making these statements, but proving them, proving that they're true. Okay. So technically, like when we learned that tangent is equal to sine over cosine, that was an identity. That is a statement giving a relationship between different variables. And again, we talked about why that was true. We could formally prove why this is true, but this is an example of a very, very simple identity. Another identity is this one. Cosine squared of theta plus sine squared of theta is equal to 1. So let me just explain where that one comes from. First of all, I hope you can see why it's called Pythagorean identity. It looks a lot like the Pythagorean theorem, right? A squared plus b squared equals c squared. Because, and here's our friend the circle again. Okay, if I choose a point on the circle where this is theta, okay, remember that the length of that line I just drew would be 1 because the radius of the unit circle is 1. And I know my x value is my cosine and my y value is my sine. So if this is a right triangle, it makes perfect sense that cosine squared plus sine squared, whoops, that's not what I meant to write. Cosine squared plus sine squared would be equal to 1 squared. That's Pythagorean theorem, right? A squared plus b squared equals c squared. Okay, 1 squared is just 1, so that gives us this identity here. By the way, this is just shorthand here where we write cosine squared of theta. That's the same thing as saying the cosine of theta squared. I don't know why. I think we just want to avoid making it look like the theta is being squared. It's the cosine of the theta that's being squared. Okay, so cosine squared of theta plus sine squared of theta is equal to 1. Here's how you can put something like that to use. If you know that the sine of theta is equal to 1/3, and you want to try to find the cosine of that theta, I can use this identity if I want to. So cosine is the thing I don't know, so I'm going to write this down as cosine squared of theta plus, now my sine is 1/3, so I'm plugging in 1/3 and squaring it. And then I know that has to equal 1. Okay? All right, so 1/3 squared I know is 1/9. So cosine squared of theta plus 1/9 equals 1. If I'm solving here, my next step will be to subtract the 1/9. Okay, and that's going to leave me with cosine squared of theta equals 1 minus 1/9 is 8/9. And then just like anything else that's squared, if I want this by itself, I can take a square root. Okay, and from there I'm probably going to have to just jump to a calculator. So I'm going to do the square root of 8/9. Okay, and I get that cosine theta is equal, that's what happens. So when I take a square root of cosine squared, I'm left with just cosine. And I get this decimal, 0.943. Now, what we want to be careful of is because I took a square root, technically this could be positive or negative 0.943. Okay? And the reason for that is, I'm going to use this circle down below, although I'm going to be writing on it in just a minute, but I'll just give you a picture here. If I know that my angle is sine of 1, or whatever my theta is, sine is equal to 1/3. So that would be like, I don't know, 1/3 on the y-axis, that could be this location, or it could be this location. I could be in either of these spots and have a sine of 1/3. If I'm over here, my cosine is positive. If I'm over here, my cosine is negative. So that's what this identity is meant to help you with. It's meant to help you with relating the sine to the cosine. Now, are there other ways we could have figured that out? Absolutely. Some people always want to jump straight to like, well, then we could figure out what theta is by doing an inverse sine and then just do cosine of that angle. And that would be fine as long as you remember that when you do that inverse sine, there could be two possibilities, okay? But this is how this is always going to shake out. It's always going to be a plus or minus something. To be honest, this identity by itself right now is not going to be all of that important. You know, being able to do this process, you'll want to know it, but this becomes very, very important when we start doing our proofs of trig identities. So we'll be revisiting it, okay? But that was not the most important thing in this lesson. This next piece is, so I've given you this picture of a circle here, and here's what I want you to kind of think about. And we've talked about this before. I know we went over a homework problem that covered this same thing. Let's suppose that I make an angle here where this is theta, okay? And we know that at this point, I've got a cosine and a sine that are both positive. Okay, that's how I would find the coordinates. I would do the cosine of theta and the sine of theta. If I go straight across the circle horizontally, if I go over here to this point, I know that this angle here would also be theta, right? And then the coordinates here, the cosine would be negative and the sine would be positive, okay? I could also do that same angle theta down here, right? So I can make this be theta. And down here, it would be those same coordinates because, again, all four of these angles are going to go together, right? The coordinates are going to be the same, except now my sine has flipped to negative. And then I bet you're guessing what I can do next. I can say this angle here. Excuse me. Sorry about that. Realistically, I'm probably too lazy to edit that out, so sorry you had to listen to me sneezing, but I could do theta here as well. We know that these angles are all related, and these. And down here, I've got a positive cosine and a negative sine. You already know that that's how the circle works, right? You already know that these four angles, whatever they happen to be, and it doesn't have to always be your exact values. It could be any angle. But you already know that those four angles are always going to be related, that their cosines and sines are just going to be positive or negative depending on where they are in the circle. I think that the trickiest part about this is understanding the kind of the mathematical lingo that goes into naming these other three angles based on this angle. So if we think about, I'm just digging for another color pen here. If we think about this angle as being our original theta, and I want to figure out where this angle is, I mean, we know this is theta, right? But it's theta going backwards from 180. So this angle here, if I'm trying to name this location, I would say it's 180 minus theta, okay? In kind of a similar fashion, if this is 180 and I'm going theta past 180, I can call this angle 180 plus theta, okay? And then this angle here, two different ways you could think about this. I mean, I usually think of this as being like 360 and then subtracting theta. So we could think of this as 360 minus theta. But typically what we do is instead of thinking of it as 360 minus theta, we just say this is negative theta, right? This is going backwards by theta, okay? So when I start talking about 180 minus theta and 180 plus theta and negative theta, all I'm talking about are the angles that are kind of related to that original one, okay? Now, of course, I'm not always going to be easy on you and use degrees, right? A lot of the times we're going to be talking about this in radians. In radians, the only thing that really changes is instead of 180, we call this pi. So we can call this pi minus theta and pi plus theta. And this one we would probably still just call negative theta. I mean, we could write it as 2 pi minus theta if we wanted, but I think negative theta is more often used, okay? That is the most important thing in this lesson, is understanding that when you know the cosine of this angle, you now suddenly know that the cosine of this angle is just the opposite, that the cosine is negative over here. And understanding when the cosine is negative and when the cosine is positive and all of those relationships is really the crux of this lesson. So now what I want you to do is kind of keep this picture in mind, but flip to that next page of your notes. And I'm fairly certain that I left all of this in here. I did not make you copy any of it because I don't think it's important enough for you to have to copy. These three theorems right here are really saying exactly what we just talked about. But look at how much more complicated they are. So just very quickly here, cosine of negative theta is equal to cosine theta. Here's what that means, is that if this is theta, and we're saying that this is negative theta, whoops, you can't see my picture, I'm sorry. So let me back that up some. Okay. If this is theta, and this is negative theta, what this theorem is saying is the cosines are the same, right? The cosine here matches the cosine here, but that the sine and the tangent both turn negative, okay? So this is saying that whatever this angle is, these two angles, whatever the sine is here, the sine turns negative down here. And then, of course, we know whatever the tangent is here, the tangent here will be negative as well, okay? That's what this is saying. The supplement theorem, you'll notice, talks about pi minus theta. So that's all focused on this dot over here. So when I do the sine of pi minus theta, it stays the same. Sine equals sine. Because sine equals sine when I'm going straight across the circle this way. But the cosine and the tangent both turn negative. So cosine is negative, and then we know the tangent at that spot would be negative as well. And then the half-turn theorem. Half-turn theorem is focused on this angle. Okay, so if I go from this angle down to this one, you'll notice both the sine and cosine turn negative, but the tangent stays the same. Okay, so I don't care that you know the wording of these angles as long as you understand what this is saying here on the circle. But the big takeaway here is that when you're doing negative theta, the cosine stays the same. When you're doing pi minus theta, the sine stays the same. And when you're doing pi plus theta, the tangent stays the same. And the other ones switch. Everything else turns to be negative. Okay, there's one more theorem here, the Complements Theorem. And I had kind of made reference to this during a homework problem. Let's see, I don't really have a good way to put that on the circle. But when I'm talking about pi over 2 minus theta, remember that would be the same thing as like 90 minus theta if I was talking about, you know, angles in a or like angles in degrees, right? This is saying that if I do the sine of some angle, it's going to be equal to cosine of its complement. It's going to be equal to cosine of the angle that is its complement, meaning it adds up to 90 degrees. Okay, let me show you where this comes from, really, because I think there's a simpler way to explain it here. If we're living in the land of right triangles here, okay, where this is A, this is B, this is C, and this is my theta, we talked about how to find this angle here, you would really do 90 minus theta, okay, because 180 minus 90 would leave you with 90, and that means these two angles have to add up to 90. And so the sine of this angle matches the cosine of this angle. So think about it. The sine of theta would be equal to B over C. The cosine of 90 minus theta, which is the complement, right? That's this angle. The cosine would be B over C. You've known about this relationship since you started doing trigonometry. Now we're just putting it in fancy math talk, okay? But what this is saying is if you've got two angles that add up to 90 degrees, you know that the sine of one matches the cosine of the other. And the best example I can think of is like 30 degrees and 60 degrees on your unit circle with your exact values, okay? Okay, so let's do a couple of quick examples here. And these are the types of questions you're going to want to know how to do as far as like your homework goes tonight. So if sine of x equals 0.681, find sine of negative x and sine of pi minus x. So let's think about this here. I like to draw pictures. You know this already. Okay, sine of x is 0.681. So that means, let's see, sine would be up here someplace. So I am either living here or I am living here, okay? Doesn't really matter which one you choose at this point because we're going to talk about how to find the other one. So I'm going to just assume that we're living in this first quadrant. I usually like to start in the first quadrant. So I know that my coordinates here are some cosine and then 0.681. And then it says, what is the sine of negative x? Well, remember, if this is x, then negative x would be down here. Okay? And so think about what these coordinates would be. Your cosine would be the same. Your sine would turn negative. So the sine of negative x would be negative 0.681. Okay? Now let's think about where pi minus x is. And this is why I said I like to stick with the same, or start in the first quadrant here, because it's easier to think about where pi minus x would be. So if I go backwards by x, which is essentially what I had written in here, if this was x and I'm going backwards by x to this point, how is that angle related? Well, my coordinates at that point would be a negative cosine, but my sine value would stay exactly the same, so 0.681. Okay, so my sine of pi minus x would be positive 0.681. So I really think that the best thing you can do for yourself in this section is just familiarize yourself with what are they talking about when they say negative x? What are they talking about when they say pi minus x? What are they talking about when they say pi plus x? You should know where all three of those angles live. Okay, so cosine of theta equals m. Find cosine of pi minus theta and sine of pi over 2 minus theta. All right, so let's draw ourselves a picture. And again, I'm just going to assume my angle is, I don't know where exactly it goes because m is not a number I can work with, but I know that this angle here has a cosine of m and then has some sine value. Okay, so now the question is, where is pi minus theta? Pi minus theta means we're going straight across the circle. Pi minus theta is this one. Where do I want to write this? Pi minus theta. Your coordinates over here, your x's are going to get turned negative. Your y values are going to stay positive. So I would say that cosine of pi minus theta is still just equal to, or no, I'm sorry, we said it was going to turn negative, so it would be negative m. Okay? Now this one, pi over 2 minus theta, that's where the sines and the cosines crisscross. So I know that the sine of pi over 2 minus theta is going to be equal to the cosine of theta by that complements theorem that we talked about. And the cosine of theta is just m, so the answer to that one would just be m. These two things are exactly the same. Okay. This is really a lesson that it's going to take you getting in there and practicing with some of these questions before you know what things you want to ask about. So give some of these a try. But again, what I would really focus on is, do you know where these things are located? The pi minus x, the negative x. If you look up here in your theorems, you'll notice these are all negative thetas. These are all pi minus thetas. These are pi plus thetas. Know where those three things are on your circle. And from there, you should be able to navigate the circle and figure it out just fine. Okay, but the hardest thing is just knowing where are these referring you to. Okay, I think that's it for us for 4.4. Go ahead and give that a try, and we will talk about the homework assignment in class next time I see you.